Hello, I'm Rebecca Simpson, and I'm going to speak to you today about time and motion studies. Time and motion studies defined as the analysis of the time spent going through the different motions of a job or a series of jobs. Some uses for time and motion studies include determining production times, delivery times, detecting and eliminating redundant or wasteful motions, computing prices, and devising incentive schemes based on production. There are a few important people in the history of time and motion studies: Frederick Taylor, Lillian, and Frank Gilbreth, and we'll discuss them briefly over the next couple of slides. Frederick Taylor is the father of scientific management. This method was used to simplify jobs and train workers to use the one best way to complete a task. Taylor became interested in improving productivity while working with steelworkers. He began performing time studies using a stopwatch to time the workers' motions while trying to determine the best way to complete the job. A couple of his best-known studies include the pig iron study, where Taylor worked with the management to determine the best schedule for lifting versus resting that allowed the workers to move up to 47.5 tons of pig iron per day. For his science of shoveling study, Taylor determined that the workers were capable of lifting about 21 pounds of material in a shovel, so having shovels specifically designed to hold that amount of material at a time would prove more efficient. And while it improved efficiencies, the scientific management method was not without criticism. Some felt that it was dehumanizing to the workers, reducing their jobs down to a single monotonous task that left them lacking in the core job dimensions of skill variety, task identity, task significance, autonomy, and feedback. Frank and Lillian Gilbreth were a husband and wife team who started their own management consulting business. They focused mainly on motion studies, with Frank's famous bricklaying study showing how motions could be reduced from as many as 18 to as little as 4. The Gilbreths worked not only to improve efficiency, but to also reduce fatigue. Lillian was especially interested in workers' mental and physical conditions. Even after Frank's death, Lillian continued to work, becoming the first female member of the American Society of Mechanical Engineers, the first female recipient of the Hoover Medal, and the first female engineering professor at Purdue University. There are several types of studies in the time and motion study family. Work sampling is the practice of performing multiple observations on one or more workers over time. The observer will have a chart of tasks drawn up and will note the frequency and duration of each task. This information is then converted into percentages to estimate how much time is spent on each task. Shown, we have examples of the task chart on the left and how the data might be converted into a pie chart on the right showing the percentage of time spent on each task. Work sampling can also be used for standard setting, but there are other methods that can be used for that as well. Stopwatch time studies, where the observer watches and records how long it takes an incumbent to finish a task, is another method used for standard setting. The analyst will take multiple measures of the task and then factor in for downtime, fatigue, and a judgment on how fast or efficient the incumbent was working and come up with a rating. The standard time will then be based on this rating along with the representative time gathered, allowances for downtime, and delays. Predetermined time systems use data collected from previous job analyses, coupled with the elemental movements of the current job being analyzed. And industry standard data is similar to the predetermined time systems. They draw on known data from other analyses, typically within the same industry, and determine the time that should be necessary to complete a task. Motion studies focus on the movements involved in completing a task as opposed to the time it takes to complete the task. Motion studies focus on the most effective or efficient way to complete these tasks. These types of studies are also used to improve the ergonomics or body mechanics used to complete the task, which helps reduce injuries on the job. Graphs and flowcharts externalize the sequence of events within a job so they can be examined to find a more efficient way. Micromotion analysis breaks movements down further from a sequence of steps to a single step and the elemental motions involved. The recording techniques used for motion studies include film, video, slow motion photography, and time-lapse photography. On this slide, on the left, we have Frank Gilbert's Thirblings. It's a collection of symbols he devised using that represents 17 elementary motions commonly found in manual operations. These symbols were used to prepare the motion study charts. On the right, there's a more modern, simplified symbol system that's more commonly used today. Conducting a motion study can be broken down into 5 steps. First, break up the operation of the job. Make a detailed list of all the steps and all the materials and equipment used. Second, question each detail of the job. At each step, determine its purpose, whether or not the step is necessary, whether this is the best place to do the step, are the steps being performed in the best sequence, is the step appropriate for this worker, or should it be done by another? Third, develop a new method. The process above should lead to the development of a new, better method. Fourth, you install the new method. The method must be approved by the organization, and then workers will be retrained. And lastly, maintain the new method. The workers must be observed to make sure they're not slipping back into old methods. There are many advantages found when using time and motion studies. These studies can improve the effectiveness and efficiency of the work process. They can help set performance standards, which are often tied to incentive pay programs. These studies can help find the best practice to complete a task and can help create safer, more ergonomically friendly work procedures. On the other hand, these types of studies are not applicable to jobs that lack repetition, are not standardized, and do not involve direct labor. They're not as effective when the pace of the job is set by a machine rather than by the human workers, and when coupled with incentive programs that are tied to producing more and faster, quality may suffer. And the presence of an observer may affect how workers do their jobs. Some may even refuse to participate at all. Thank you for your time and attention.